Good evening. My name is Mihali Kambouris. We are Qauia Aid. Over the past 10 weeks, myself and my 3 other peers listed below have been set to investigate the current settlement of Kauai, Fiji, and work promptly in responding to Arcadis' vision. Throughout this presentation, we have outlined the journey of our research and investigations where we elaborate on making the Arcadis vision a reality. Kauai, a small town concealed amongst the hilly terrain of Fiji, is a place seen for opportunity for people to receive a decent education, accessibility to superior health services, job opportunities, and more. However, diving deeper into the current living conditions of Kauai, we noticed the unfortunate effects of flooding and paid close attention to how this has disadvantaged the town's facilities and systems. In helping Kauai, we have teamed up with Arcadis in order to propose promising future plans for the town.
As a group, we undertook several activities to analyse the Qauia settlement. These included an empathy map for the Qauia residents, a power interest matrix, a stakeholder map, and a Qauia radar graph. During these exercises, we were able to identify all the relevant parties involved in the Qauia settlement and its redevelopment, where these aforementioned parties sit in terms of having power and influence over the project, and where their interest levels reside. The radar graph allowed us to have an easy overview of the environmental, health, food, social, economic, and political context in the settlement, where they sit on the scale and what needs to be worked on to be deemed sustainable. Finally, the empathy map allowed us to really establish an empathetic design approach in the weeks to come by critically thinking about how residents in the community would feel, think, do, and say during the project.
To help the team better understand the impacts of the settlement's problems and to be inspired to help it, we sought out to imagine a desirable future for Qauia and then look at how well the settlement would fare if all the problems we identified were fixed. This emotive narrative we made would also give us a good idea of the extent of how the residents of the settlement's lives would be changed. With a lot of work in fixing the main issues of the settlement, we will be able to see a positive change and then motivate us to collaborate, develop interventions, and achieve such future for Qauia. We imagine the drastic flooding problem to have been fixed through the hard work of Arcadis, the governments, and the Qauia residents themselves, and is no longer a threat to the settlement. This would then allow us to imagine how the water sanitation would be improved, how the infrastructure would become better, how the environment would thrive, how the vegetation would flourish, and much, much more, all due to the hard work of solving the flooding problem together.
With the use of a backcasting timeline, my team and I were able to map out the major developments in making Qauia a sustainable community by the year of 2050. Our vision is to create a sewer and stormwater network within the settlement. We believe that 2028 will be the best year to start implementing the network in Qauia. This is critically mapped out in the intervention timeline. By the year 2040, the sewer network will start to expand to the neighbouring towns near Qauia. This intervention has been critically explored through a SWOT analysis. Our intervention will cohere with the human need of substance. The sewer system will allow the control of waste management and sanitation within the settlement. This also fulfills the Maslow's hierarchy. Our main design concept revolves around the implementation of a sewer and stormwater network. We believe this will ultimately result in stopping the floods in Qauia, as well as making each household much healthier by having proper toilets replacing septic systems. This will create a sustainable and economically friendly society. To make this intervention possible, sewer and storm mains will need to be installed throughout the settlement. The sewer mains will lead to a low-lying sewage treatment plant, whilst the unwanted floodwater is transported to the ocean using pumps. To properly and efficiently build the system, construction workers from the community will be employed, creating hundreds of jobs. To make our intervention a reality, our plan is to collaborate with representatives of the Lamy Council and Fijian government for funding.
Currently in the Qauia settlement, the community uses septic systems, which during the floods are contaminated, polluting the integrity of the river water. This constant destruction of the current septic systems requires professional evaluation and repairs before they can be deemed usable again, which is why health departments strongly warn against the implementation of septic tanks in flood-vulnerable areas. Even though a septic system is considerably cheaper in the context of the Qauia settlement, it is just not a safe and resilient option for the future. This is why a sewer system would be a more viable option for the settlement. A sewer system can take on large amounts of stormwater and heavy downpour, providing circulation for floodwaters to dispose to, without contaminating them with sewage waste. With a fairly large-scale intervention being proposed for the settlement, it is safe to say that it is likely to be very dear in cost. Therefore, specific avenues and considerations have been taken to alleviate the costs, such as materials. Materials can be considered to reduce costs by using cheaper and easier to construct materials, which will lower costs and labour hours. PVC was chosen over concrete pipes because of the following reasons. Cement concrete pipes are not durable comparatively and have a shorter lifespan because they are corroded by sanitary sewage gases. These pipes are easily corroded when acid discharges travel through the sewer or where the momentum is not adequate enough to prevent the septic circumstances, or where highly acidic soil and with an abundancy of sulfates is found. PVC does not experience these issues. Its lightweight and ease of installation reduce transportation and installation cost, yielding further benefits to the environment compared to concrete use. PVC piping is one of the world's most sustainable products, making it ideal for long-term use in underground infrastructure, which would be economically beneficial for the Qauia settlement with the reduction of maintenance costs. PVC manufacturing requires less energy and fewer resources compared to other materials, and its fabrication leaves practically no waste. As a raw material, PVC is energy efficient to develop, with the production of resin being predominantly derived from salt, which has a virtually unlimited supply, and a domestically produced natural gas, seeing a reduction in imported oil consumption. This type of piping uses the least amount of non-renewable resources during its manufacturing and transportation stages, with its manufacturing being extremely efficient compared to other materials, with essentially 100% of the material being utilized, and its creation using 4 times less energy than a concrete pipe. PVC is a recyclable material, even though its excessively durable nature could arguably eliminate the question of disposal. PVC is widely known for its elimination of water loss with leak-free joints, corrosion resistance, reduced pumping costs because of its smooth surface, and exceptional durability, which after a recent study by the American Waterworks Association Research Foundation established PVC pipe life expectancy at more than 110 years. All of these attributes resulting in better water conservation and lower replacement, maintenance, and repair costs. Reduction of transportation and installation costs because it is a lightweight and easy to install material reaps further benefits for the environment, thus making PVC piping a sustainable choice for the sewer system being implemented in the Qauia settlement.
After making key design considerations and decisions, we were able to begin implementing the sewer network into the settlement. To begin with, analyzing the topography was important. As gravity plays a major role in the sewer system, we first gauged how the river ends up flooding the settlement and found that due to the river and the settlement sitting adjacently in a low-lying area between 2 high hillsides, the river and floodwaters encroaching onto the settlement is at a higher chance than normal when rainfall or other weather events happen. Next, we saw that the settlement is mostly on a gradual decline going towards an open, low-lying area, which is perfect for when pipes are being placed and for sewer treatment plant placement. The general layout and organization of both the sewer mains and storm mains, along with the sewer treatment plant placement, are shown on the left. A primary sewer main runs just under the long street, which stretches across the whole settlement and connects to the secondary pipes that connect to eligible houses. With the settlement all connected up, it all travels to the sewer treatment plant to get properly treated and dealt with, which means that residents aren't using the river as a dumping site and further creating sanitation issues. A storm main runs next to the primary sewer main, and in conjunction with storm drains in the road, It will help to transport wastewaters, floodwaters, and other waste away from the settlement to be disposed of in the nearby oceanside. The use of a lift pump will be necessary to pump the wastewaters up a hillside to get to the nearby ocean. This will ultimately become a substantial defense against the floods, where the waters are being disposed away instead of spreading further and further onto the settlement. The sewage treatment plant is being placed in a low-lying area as it is intended to be, with all the gravity-led sewer pipes being connected to it. The plant will process and remove contaminants from the wastewater of the settlement, such as household sewage and other waste. With a plant having to be in a low-lying area due to the pipes, it can possibly be affected by some flooding due to the proximity to the river, which is why the plant will feature flood-resistant constructions, as well as elevating as much of the plant as possible and ensuring the building can be sealed off. Overall, with a proper sewer system in place at Qauia, the settlement will reap the benefits majorly, and the residents of the settlement will be able to live their lives much better now, and can focus on progressing the settlement itself without fear of flooding and bad sanitation ruining everything. The settlement will be much more resilient towards their flooding problem and can focus on other facets of